Malaysian 370, contact Hokkaiman 1-0.9. Good night.
This was the last communication. This is the silence that followed. And this is the single greatest aviation mystery in the history of the modern world. On March 8, 2014, Malaysia Airlines Flight 370, with 239 souls on board, vanished from radar screens. It did not crash. It did not send a distress signal. It simply ceased to be. In the decades since, we have been fed a diet of wild theories. Was it a hijacking? A pilot suicide? A UFO? A black site kidnapping? The noise is deafening. But what if I told you that buried beneath the speculation is a cold, hard, and terrifyingly precise story told not by people, but by machines? Welcome to Method and Mystery. I'm your name, and today we are silencing the noise. We are going forensically, mathematically, and digitally deep into the only evidence that cannot lie. The data. This is the disappearance of flight MH370, the data. By the end of this investigation, you will see the ghostly digital fingerprint of this flight's final hours. You will understand what the satellite pings actually tell us, and you will see the chilling, narrow corridor where the wreckage must lie. This is not about conspiracy. This is about calculus. If you are ready to replace speculation with signal, you need to subscribe to this channel right now. What we uncover here is the closest thing to truth we have. Hit subscribe, and let's follow the data to understand the mystery. You must first understand the normal. Flight MH370 was a Boeing 777, one of the safest, most technologically advanced aircraft in the sky. It was a data-generating machine. Its systems communicated via two primary methods: transponder data, the plane's identity and location beacon for air traffic control radar, and a CAS, the aircraft communications addressing and reporting system, a digital data link that automatically sent maintenance and performance reports via radio or satellite. At 1:19 a.m., over the South China Sea, the CEO pilot gave the final, utterly normal sign-off. Good night. 1 minute later, the plane's transponder was manually switched off. This is the first critical data point and act, not a failure. Someone in the cockpit deliberately made the plane invisible to civilian air traffic control. But this is where the popular narrative often stops. The plane vanished. That is false, because the plane had a third hidden line of communication. A heartbeat no one could switch off without destroying the plane entirely. Its satellite data unit SDU. This SDU was designed to periodically handshake with a communications satellite owned by the British company Inmarsat, orbiting 22,000 miles above the Indian Ocean. Think of it as the plane's phone, quietly pinging the satellite every hour just to say, "I'm here," even if it's not making a call. When the transponder went dark, this humble, automated ping became the sole tether between MH370 and the known world. It is the thread we will now follow into the abyss. The Inmarsat satellite received 7 of these automated handshakes after the plane's disappearance. They contained no location data, but they held something just as valuable: a timestamp and, crucially, a measurement called the burst timing offset and the burst frequency offset. This is the core of the mystery. Let's simplify. Imagine you are standing in a field, blindfolded. A friend somewhere in the field claps once every hour. You cannot see them, but you can measure two things with perfect accuracy. First, how long the sound takes to reach you, the timing offset. This gives you a distance the clap took to seconds, so they are about 700 meters away. You now know they are somewhere on a circle around you with a 700 meter radius. Second, you can detect a tiny shift in the pitch of the clap, the frequency offset. This is the Doppler effect, the same reason a siren sounds higher as it races toward you and lower as it zooms away. By measuring this microscopic frequency change, you can deduce whether the clap was moving toward you or away from you, and at what speed. The Inmarsat satellite was the listener. Each ping was the clap. And through brilliant forensic analysis, a team of mathematicians and engineers used these two measurements, time and frequency, to draw two historic arcs on the map of the Indian Ocean. The first arc, from the timing offset, gave a distant circle. Each ping placed the plane on a gigantic, thin circle on the Earth's surface, with the satellite at the center. The seventh and final ping created a circle about 2,200 kilometers west of Perth, Australia. The plane was somewhere on that immense ring. But which point? This is where the second measurement, the Doppler frequency shift, came in. By analyzing the subtle changes in frequency across the 7 pings, analysts could determine the plane's speed and, more importantly, its general direction relative to the satellite. They could tell it was flying away, not toward. When they modeled flight paths that fit both the timing and the frequency data, the possibilities collapsed from an infinite number of points on a circle into two broad, but profoundly telling, corridors. A northern corridor stretching over land from Thailand to Kazakhstan, and a southern corridor arsing deep into the remotest stretches of the southern Indian Ocean. The data could not pick one, but human logic could. Because if the plane had flown north over densely populated Asia, with countless military radars, someone would have seen it. No such sightings occurred. Therefore, by a brutal process of elimination, the investigation concluded the plane had taken the southern path. It had flown for nearly 7 hours on autopilot, in radio silence, on a zombie flight into emptiness. But the data has more to say. Let's talk about the final maneuver. Primary radar from the Malaysian military, a system that paints blips based on raw radio wave reflection. Not transponder signals, tracked an unidentified aircraft, making a dramatic, sweeping turn west of Penang Island. It turned south, then later southwest, navigating waypoints that suggest a deliberate flight path was entered into the flight management computer. This was not a plane out of control. This was a plane being flown, or at the very least, programmed. This radar data, combined with the satellite pings, allowed investigators to perform a reverse engineering miracle. They took known performance data for a Boeing 777, its fuel burn rates, its cruising speeds, and they ran thousands of simulations. They fed a virtual MH370 with its known fuel load onto the southern corridor and let it fly until it ran out of gas. Where would it glide? Where would it impact the water? This probabilistic modeling produced a priority search area thousands of square miles wide. But it was a mathematical guess baptized by data. And it is here, in this vast, storm-ridden stretch of sea, that the most haunting chapter of the data story was written. On July 29, 2015, 2 years after the disappearance, a piece of flapper on a wing component washed ashore on our Union Island, over 2,500 miles from the primary search zone. It was positively identified as from MH370. This was the first physical proof the plane had ended in the water. It was also a data point that confirmed the broad southern track. Oceanographers then performed a staggering feat of reverse drift modeling. Using detailed maps of ocean currents, winds, and sea conditions, they simulated the backward journey of this debris. Where would it have had to enter the water to arrive at our Union at that time? The models pointed again to the general vicinity of the 7th Arc Search Zone. Other confirmed pieces found in Madagascar, Tanzania, and South Africa further refined this drift data, creating a scatter plot of grief that, when fed into the models, kept pointing back to that same remote zone. The machines, the satellite, the radar, the flight simulator, the ocean current model were all telling a coherent, if horrifying, story. So, what does the data exclude? It ruthlessly dismantles the sexier theories. A mid-air explosion or sudden catastrophic failure would not explain the deliberate turn, the transponder shutdown, or the 7 hours of powered flight. A shoot-down by a military aircraft would have created debris fields spotted by satellite. The black site theories, suggesting a landing in Central Asia, are annihilated by the satellite pings placing the plane in the remote southern hemisphere and the lack of any radar contact over dozens of countries. The data forces us into a narrow, uncomfortable, but logically airtight scenario, a controlled, deliberate act that led to a long, lonely flight ending in a dark sea. The what is clear. The why is the enduring human mystery that the data cannot solve. This is the power of a methodological approach. We follow the evidence where it leads, even when it leads to a terrifying, unsatisfying void. The story of MH370 is the ultimate testament to the fact that in our hyper-connected world, true disappearance is almost impossible. The machines are always watching, always logging. They leave a ghost in the machine. If you understand now that the greatest mysteries are not solved by guessing, but by listening to the silent testimony of data, then you belong here. Hit that subscribe button. On Method and Mystery, we are dedicated to this principle. The signal is always in the data. The noise is in our imaginations. By subscribing, you are joining a search for signal in a world drowning in noise. Click the bell, because in our next investigation, we will apply this same forensic data analysis to a mystery from the ground, the eerie patterns and chilling evidence behind the Dyatlov Pass incident. We will separate the mountain's facts from the legends. The ocean is vast. The data is precise. Between the two lies the truth about flight MH370. Stay curious, but trust the calculus. This has been Method and Mystery.